Okay, get ready to take notes. 3.4. This is called linear programming. So don't freak out about the assignments right now, right? You have until tomorrow to get them all together. So if you don't have them all stapled today, it's totally cool. You can finish doing it tomorrow. Preferably in the correct order to make it easier for us to put them in. We've got 165 kids we have to enter like 4 or 5 assignments for. So that's some big numbers. Yeah. Big numbers. We're almost, it's been what, 7 weeks and we're almost got it totally down. The assignment thing, it's not quite yet. It's like torture. Okay, linear programming. What we do with these linear programming is we're just going to teach you the process today. Tomorrow we're going to look at some story problems and try to do linear programming with these story problems. Okay, so just process today, using equations, graphing them, figuring out corners of the feasible region, and plugging them into an objective function. So first, we've got some definitions to talk about. First thing we need to talk about is constraints. So constraints are really just limits. So we have limits because constraints. So if we're producing something, let's say we're producing like corn and soybeans, right? We can't produce negative corn and soybeans. So you'll always see in these problems these constraints where x has to be greater than 0 and y has to be greater than or equal to, I should say, 0. Always the case in these problems, okay? Now, because you get used to always seeing these constraints, it's really easy to forget to write these on your test. This test question is going to be worth 8 or 10 points, right? Going to take up an entire page of your test, and this is an easy thing to forget. It would be -1 out of 10 if you forget these constraint equations. Okay, so with these constraint equations, which quadrant does it force the graph into? Into quadrant 1. Remember, quadrant 1's upper right, quadrant 2 upper left, quadrant 3 lower left, and quadrant 4 lower right. So we're always going to be graphing these things in quadrant 1 because both x and y will always be positive. Alright? Can't produce, if we're talking about t-shirts and sweatshirts, that's what the big problem we're going to do tomorrow. Can't produce negative of those, right? Even if you're going into bankruptcy, you still can't produce negative anything. You just don't sell much. That's why you go into bankruptcy. Okay? So that's constraints. Next thing we're going to talk about, we'll just do rough little graph here. Not with highlighter though. Rough little graph. Like this. We'll end up graphing 2 lines. Let's say the lines look like this. Your feasible region, so we're going to be graphing lines with inequalities, and your feasible region will almost always, I can't say always, but almost always be in the corner by 0, 0. Okay? And what you're going to have to figure out is the corners of the feasible region. So we're going to take the corners of the feasible region and we're going to plug them into usually a profit equation called the objective function. Okay? So we're going to have some sort of profit. It could also be an equation where we're trying to minimize. So an example of an equation where you're going to minimize would be if you're on a diet, right? You're trying to minimize your fat intake. But we're going to do problems where it's going to be maximizing. Alex?
Why did you say that liver was a complex?
Because we're going to do these equations where it's less than both equations, right? So where it's less than both and then greater, right? X is greater than 0, Y is greater than 0. So it's going to tuck into the corner, basically. I can't say always because there's always an exception, but 95% of the time it's going to tuck in there. Yeah. It's a graphing problem. You have two inequalities to solve, plus the X is greater than 0, Y is greater than or equal to 0. So that's 4 inequalities, right? And then you're going to figure out the corners of these regions, and you're going to plug them into your objective function and figure out which of these 3 points gives you the maximum amount. Right? So if I'm a farmer, I'm planting soybeans and corn, I want to figure out how much of each I should plant to be able to maximize my profits. Okay, if I'm producing, the problem we're going to do tomorrow is going to be with t-shirts and sweatshirts. I want to figure out how many sweatshirts I should get and how many t-shirts I get so I maximize my profit. Okay, so it's directly applicable to what we're doing here. So your objective function, you're going to use that to figure out either maximizing or minimizing your quantity. Okay, so objective function, I almost don't want to write minimize. Yep. Objective function will use the corners of the feasible region. To either maximize or minimize. Yep, minimize. And like 95% of the time we're going to be maximizing. Plug in the corners to figure out which number is biggest, and then we're going to answer the question basically. So all we're going to do today is we're going to graph using the X is greater than or equal to and Y is greater than or equal to 0. We're going to use two different inequalities, right? Graphs of lines, and then we're going to figure out the corners and we're going to plug them into an objective function. I'm going to show you how to do that graphing by hand as well as in your calculator. We'll literally do 2 examples and we'll take up the entire lesson. Okay? And that's without a story problem. They can kind of understand the scope of how big these problems are, because it gets way more difficult when you have to write, right? You've got 5 equations you're going to write on these problems. Okay? 2 of them are easy. X and Y is greater than or equal to 0. But you got to be able to come up with 3 more equations from the story problem. Okay, so to get over your story problem phobia, because it's coming. Okay, first example we're going to do is going to look like this. So we're always going to have the X is greater than or equal to 0, Y is greater than or equal to 0. And then we're going to do these 2 equations, X plus 2Y is less than or equal to 5. And we're going to have x minus y is less than or equal to 2. And then our objective function is going to be p equals 2x plus y. So first equation to graph it, this equation right here, what do we have to do to be able to graph it? Y equals mx plus b. So what's the first step, Kendall Raymer? Subtract x from both sides, good. So we have 2y less than or equal to negative x plus 5. What's the next step, Maddie Wood? Want to get y by itself here. Divide by 2, all three parts. So what we get here is y is less than or equal to. I don't want to write my slope as negative x over 2. I want to write it so I know what to do with the slope. So how do I make a fraction out of negative x over 2? Right, negative 1/2 x. I tend to always put the negative in the numerator. I like to do things the same way, right, because math works like that. So negative 1/2 x plus, and how about we use 2.5 instead of 5/2. So this is going to be our y-intercept, 2.5. Okay? So how about the second equation? What do I have to do, Mariah?
You want to add the y? Or you're trying to do this together?
Try to get y by itself. I want you to leave the y on the left. Subtract x. It's all easy stuff you've been doing before. Less than or equal to negative x plus 2. I'm writing the x term first, so it looks like y equals mx plus 2, right? What's the next step, Stephanie? Divide all three parts by negative 1. So what do I get, Kendall Haight? So if it helps you to put the 1 over 1 as the slope there, put it. Right? I could also go, instead of up 1, right 1, I could also do what? Down 1, left 1. Does that answer your question, Emma, or do you still have a question?
I was confused on how the native speech was there.
You got it? Okay. So really critical when you're graphing these things, you have to solve for y correctly, otherwise your answer is massively incorrect. Right? Because I want to shade not below this line, but above this line. Okay? Because I have to flip that inequality. Alright, so let's graph these two things. So again, we're going to be in which quadrant? Quadrant 1. Because of the x is greater than or equal to 0 and the y is greater than or equal to 0. So all you need to show in your graph is quadrant 1. So I'm going to skip space. I'm not going to make one like one of these little squares, right? I'm going to make it a little more than that because it just works out better. Otherwise the graph is all tiny. So let's do it. I did this problem second period, so I'm going to show a little bit of quadrant 4 because it'll graph better. So show it like that. So the very first graph starts where? 2.5, right? So I'm going to go up 4 spots. This little box, there we go. So call that 1. Call that 2. In my second equation, what's my y-intercept? -2. So I gotta use -2 down here. So 1, 2, 3, 4. That's -1. That's -2. Okay, same thing over here. I'm going to go with that +1 and +2 on the x instead of 3. Instead of 3 up here, 2. So I'm just changing the scale on my graph so I can see the graph better. That's why I'm skipping all these spaces. So we need to graph this first line. Y is less than -1/2 x plus 2.5. So 2.5 is going to be right here. We'll graph the first line in blue. What's my slope tell me to do with that first line? Down 1, right 2. So if I go down 1, it's right here. And then there's right 1, there's right 2. And then we go down 1 again to here, right 1, 2. Y is what? Y is it down 1 over 2? It's down 1 over 2 because here's our slope right here. Okay, so -1/2. So we're going to draw that line in. So it's really important to graph these as perfectly as you can. But I'm going to show you how to double check it on your calculator. But the issue with double checking on the calculator is that I'll teach you it, and then a lot of times you guys won't double check on your calculator, right? If you have a system of equations and you're doing elimination, I taught you how to plug that in using matrices in your calculator. How many people did that on the quiz to check their elimination? So 1 out of like 31 or so I have in here, right? Good job. But use those strategies I give you. You also want a backup plan. The reason the backup plan is helpful is if all of a sudden stuff goes horribly wrong, at least you have the correct answer and you can figure it out from there. Okay, so if you're not going to use the backup plan, you have to graph these things incredibly well. So our second equation started at -2, and we're going up 1, right 1. So we start at -2, and we're going up 1 and to the right 1. So starting at -2, and we go up 1 to the right 1, and we go up 1 to the right 1. And then we're going to graph that line. So this intersection right here is really important because that's going to be a corner of one of our feasible regions. That's going to be another corner, and this is going to be your third corner. Yep.
So why does it start on the bottom part instead of
So why doesn't it start up here is what you're asking me, right? Because the y-intercept of that second equation was -2. So when I give you one to graph by hand, it could start in the negative, right? Normally what will happen, like that first quick sketch kind of thing I showed you, is both lines will start, right, on the positive y-axis, and you'll just have different slopes, and that'll give you your feasible region. But in this example, because we're just graphing by hand, it's not going to look like that. Okay? So both equations, we have one equation that is less than, right here. So the blue line, we're graphing less than, and the red line, we're graphing greater than. So where am I going to shade? Describe it in words. Can you describe it, Maddie? Because Maddie's pointing.
Like, 2.5, or 0 to 2.5, and then all the way, yeah, that.
Right in here, right? We're going to graph kind of in the corner. I think about that being in the corner, right? By 0, 0. And then towards the positive on both X and Y. That's where we're going to shade. So if I shade this thing, it'll be all in here. Because I'm graphing less than the blue line and greater than the red line, right? So the x-axis is really y is equal to 0, right? Because it crosses the y-axis, that's 0. So it's greater than the x-axis and greater than the y-axis, okay? So we're going to graph that in the corner. So we got to figure out what this point is. What's the coordinates of this point? 3, 1. So if you don't graph it correctly, right, that can be problematic. What are the coordinates of the other corner here of the feasible region? 2, 0. So also very important that you do the x in the right place and the y in the right place, right? My x value here is 2, y value is 0. So this point is 2, 0. And then this point up here is what? 0 and 2.5. Okay? Good. So this point right here is 0 and 2.5. So we have that objective function, which was p. We could think of the p as profit, 2x plus y. Just double check that. So p equals 2x plus y down there. So I'm going to write that objective function up here. So what you guys are good at doing on a test is like cranking out the algorithm of the problem, like the process of the problem. That's what I mean by algorithm. You guys are good at that, but kind of thinking as you do that is what some of you, not all of you, what some of you struggle with. So I want to think about the corners of the feasible region and figure out which one's going to be the answer. Raise your hand if you know which one's going to give you the greater value right now. Just think about plugging in 3 and 1 for x and y. Think about plugging in 0 and 2.5 for x and y. And then thinking about plugging in 2 and 0 for x and y. Raise your hand if you know which one's going to give you the greatest value. Janet, which one? 3 and 1, right? So, you can, right, if you're confused by that, just plug in all 3 points. But I can look at these values, right? And if I look at the 2 and the 0 and as compared to the 3 and the 1, 3 is bigger than 2, right? And 1's bigger than 0, right? So I don't have to plug that one in because both x and y are bigger. You get that? So it saves you some work if you can realize that. If not, just plug all 3 in and see which one gives you the biggest number. And then if I plug in 0 and 2.5, 2 times 0 is 0, all I have is 2.5 left. Right? If I were to plug in this 2 and 0, I would get 4 here and 0 here. So even this point's bigger, right, than this point. So again, you can think about all those things, and then all you have to end up doing is plugging in 1 point. And as long as you plug it in correctly, you're going to get the correct answer, right? Julianne? Yep, you're trying to find the biggest answer. We're trying to maximize the objective function right here. So if you can't just tell by looking at them, just plug all 3 in and you're going to get the correct answer anyway. Alright? So I'm just going to plug in the 3 and the 1. So 2 times 3 plus 1, what do I get? 7. So P equals 7. Griffin, that's your final answer. So, kind of multi-part answer, right? When I grade this problem on the test, I'm going to be looking for the shading. I'm going to be looking for the corners of your feasible region, as well as this answer. So that's why it's worth a lot of points, right? Because there are a lot of different parts. Yeah, so that's a good point, Becca. That's a good question. So if I plug in 0, 0, it's always going to be the smallest, right? So I just kind of forget about 0, 0. No. If you shade in here, then you're going to lose points, right? Right. Right. Okay? We good on that? Not that bad, right? What makes it nasty is when you have to write the equations for these inequalities from a story problem. That's what makes it hard. And then you also have to write this objective function from the story problem. Okay? So that's what makes these hard. But it's important to get this process down first. So let's do the same problem in the graphing calculator, because when you do the story problems, you're going to get bigger numbers than 2.5, right? It's going to be all big numbers, and it's going to be way harder to figure out where the two lines cross. So I just want to go over where the two lines cross. So bust out the graphing calculator, and first thing you want to do is hit y equals. And actually, you know what we'll do? I always have problems with all these different graphing calculators. Let's just reset your calculators so we all start at the same place. So to reset, we'll go second plus. And you want to choose option 7 here, reset. So second plus, choose number 7. And then, I don't know why resetting the RAM works better, but we're going to reset the RAM. So second plus, and reset your RAM. And I don't know if all your screens look like that. I'm just curious more than anything. Yeah. So we go second plus. We're going to choose number 7, reset, and then choose the RAM, and then go down to number 2, reset. Okay. Anyone need help doing that? So if it's me before a test or a quiz, I'd reset it, right? Because you may have funky windows and stuff from doing problems, and that could be problematic. Copy?
So when you get like the human points on the graph, box,
Yeah?
well, you do like the trace.
Yeah. That's what we're going to do. So hit the y equals. So our first equation was negative 1/2 x plus 2.5, right? Is that the first equation? Yeah? Okay. So negative, make sure you hit the negative, not the minus sign. Because we reset it, it'll take all that stuff off, and you're starting where I want you to start. Yep? Your calculator doesn't like when you use the minus. You'll get error messages. Okay? So when it's a negative in front, you always want to use this negative button. So negative 1, the way you do a fraction is just hit divide. Negative 1/2 x plus 2.5. Yep. Y equals. Okay, Emma?
Where did you get the 1/2?
From the equation.
No, I mean like on the calculator.
Oh, I just hit divide.
Oh.
I do 1/2. You could even do negative 0.5 if you want. Yep. No, it doesn't. If you freak out about parentheses, put parentheses. Like if it makes you feel better, just put the parentheses. When I took calculus, I overuse parentheses because it gets so complicated, you're not sure what the calculator is going to do first. So I just use parentheses, so I made sure the calculator did what I wanted to. So you can do that too. Second equation was x minus 2, right? X minus 2. So you want to hit the minus now. And then we're going to hit graph after you get that in. It was this one.
Why didn't you put?
I already put this one in, right? And now I'm putting this one in. Yeah. You don't need the 1 over 1. Exactly. So big graph. So I want to double check, because it's really important, where these intersect. Because if you graph and you mess that up, right, your graph's not perfect, you're going to get something other than 3, 1. We know it intersects with 3, 1, right? But when you're graphing using numbers like 100 and 120, the intersection is not going to be as clear. So to do intersect, what do we hit? Second trace intersect. So second here, trace right here. And then intersect is number 5. So second trace number 5. And then that's where it says first curve, you hit enter. It says second curve, you hit enter. It says guess, you hit enter. And then it'll tell you what the answer is. So essentially I just say enter 3 times. And it tells me that intersection of 3, 1. Yeah, that's good. So I hit enter 3 times. Okay, so everyone get 3, 1 as the intersect? So first curve is just one line, second curve is the other line, and then I don't know why it says guess, it indicates to me when it says. Why what?
I don't know, it shows on my calculator, first curve.
The cursor could be anywhere, it doesn't matter. You just hit enter 3 times. Once you get to that window, you're good. Okay, so it intersects at 3, 1. Now let's say I want to figure out, this intersection. Let's say we want to figure out this intersection, right? So we're going to talk about this intersection first. So what does y equal right here? 0, right? So remember we looked at the table? If you go second table, so if you go second table, right here, let's look at that real quick. Yep. So if we want to figure out, so the first line we put in, right, the y1 is the 2.5, right? So we want to figure out, if we think about the graph, we want to figure out this point right here. So which line is this? Where's across the y-axis? -2, so this is the -2 line, right? So we want to figure out where y equals 0, what does x equal? So we're looking at this column, right? Because here's our y-intercept, -2. So where y equals 0, what does x equal? 2, right? So where y equals 0, x equals 2. So that's one way you can figure it out. Okay, here's another way you can, do you want the other way to figure it out? It's going to be too much. Yeah. You're going to learn both of them eventually. Maybe we'll talk about this tomorrow. Thank you. Okay. Okay, so what do we have? 12 minutes left. You want to do one more of these? You all should be saying yes. We're going to do word problem tomorrow. It'll literally take like half hour, 40 minutes to do. Just one example in class, right? When you do it on your own, it should take you about that one question on the test. Will literally take you about 20 minutes. Right. I mean, we know that one because it's a y-intercept, so you won't have to figure that out. Because the other corner will be one of the two y-intercepts. Right? It's not going to be this one because we're in the negative, right? It's going to be this one. But this one's the more tricky one to figure out. So I intentionally didn't teach you that, but all I really care about, because I know what's coming, right, is the feasible region. So essentially all you're doing is picking points within the overlapping shading. So I think it's stupid to do a table, so that's why I didn't, but then I forgot to tell you to ignore those directions in the homework. Just graph them and shade them. That's really all I care about. Picking points in the feasible region is also stupid, right? Because who cares? Like, you're shaded, you can tell, right? A child could pick points out of it. Yeah. Julianne, what's your question? And then Anna. Second trace intersect. And then if you want to look at the table, you hit second graph. Gets you to the table. Okay? So yeah, you can have the rest of the 10 minutes to compile homework that you have, attach them to the little sheet I gave you.